All right, first thing to notice, you've got the angle theta lying between 3 pi over 2 and 2 pi. So when you draw your triangle, remember 0, pi over 2, pi, 3 pi over 2, and of course that's 2 pi over here as well. So if it's between these two, that means your triangle will be in this quadrant, right? It's just a sketch. So if tangent of theta, here's our theta, this thing all the way around, our theta is right in there. It's our reference, even though theta is the big angle on the outside. That theta reference says that the opposite over the adjacent is 4 over 3, right? And it's nice. This says negative 4/3. That makes sense because it's down, negative 4. And hopefully at this point you know that this is a 3, 4, 5 triangle. If you don't know that off the top of your head, of course you can use Pythagorean theorem to figure it out. So once we know what theta is, we're supposed to now use sine or find sine 2 theta, and we should use our double angle identity. And that says that the sine of twice an angle is equal to 2 times the sine of an angle times the cosine of that angle, right? So what we're doing is we're saying, hey, if I know what sine of this simple angle is, then I can just use this identity instead of worrying about twice the angle. So that means I've got 2 times sine of theta times cosine of theta. Well, sine of theta, of course, is going to be the vertical value right here. It's the negative 4 over the radius, right? So opposite over hypotenuse. The cosine of that angle is 3 over the hypotenuse. So sine of 2 theta should just be 2 times negative 4 is negative 8. Negative 8 times 3 is negative 24. And 5 times 5 is 25. There you go.